we can continue with the heat exchanger. Okay, so for heat exchanger, saya rasa everyone knows, especially after you do this your heat exchanger project. Okay, so there are apa tu? First, you can calculate the duty of heat exchanger. So you can calculate the Q. So this is the general equation, mCp delta T. So if for cold stream, that means you have subscript C, okay, MC, CPC, TCO minus TC out. For hot stream, then MH, CPH, THI minus TH out. Okay, so because you can assume that there is no heat loss, so QC is equals to QH, and you can also make it equals to Q, which is calculated using overall coefficient. Okay, so these are the three important equation that you can use to calculate the heat exchanger. Okay, so delta T min ni you tahu kan definition? Ada siapa-siapa tak tahu delta T min? Okay, I hope that you know. Okay, so heat transfer via heat exchanger process. So actually dia nak transfer Q from hot stream to cold stream. Okay, so my question here, what are mechanism of heat transfer that involve in heat exchanger? Anyone can help me? So kita ada three mode of heat transfer.
Is it Dr. Conduction, convection, radiation?
Okay, conduction, convection, radiation. Okay, good. Okay, so conduction, convection and radiation. And two methods involved for calculation heat exchanger, which are, kita ada dua methods. Satu LMTD methods, lagi satu, which one? So here we have LMTD and lagi satu apa? Anyone? NTU, very good. Okay, NTU. So, very good NTU. So dekat mana yang NTU ni sangat applicable berbanding dengan LMTD? Can someone write the answer or tell me the answer? When is the method specified for NTU ke LMTD is more applicable? Anyone? Part ni yang very important juga. So this is how you analyze the equation. If no T out given. Betul Nur Syahira. Okay. Kalau if no T out given, kita nak guna yang mana satu? NTU ke LMTD? Syahira tadi? NTU. Very good. Okay. So that's how you analyze the question. So, okay. So tadi kita ada sebut yang mechanism heat transfer that involve in heat exchanger ada conduction, ada convection dengan ada radiation. Okay. Now, what can be assumed in order to neglect conduction for calculation of heat transfer for heat exchanger? So, apa yang kita boleh assume in order to neglect conduction for heat transfer? Saya pergi dekat slide ni. Kosong ya? Okay. So, you can see it here already. What can be assumed in order to neglect conduction? Cuba tengok this part. Okay. Thin tube wall. Very good. Lygia, very good. Okay. If you have very thin wall, okay, then, okay, so you tak ada resistance due to conduction. So you can neglect conduction if the thin is very, if the wall is very thin. Okay, so then dalam soalan ni lagi adalah, sekejap, saya dah salah soalan. Okay, and then saya pergi dekat assignment 2. Okay, assignment 2 here adalah, saya akan copy soalan ni. Saya akan copy soalan ni. Saya nak minta you all sketch layout and temperature profile for 1-1 parallel flow, 1-1 counter flow and 2-8 layout. So saya akan buat pembahagi. Okay. So this one going to be 1-1 parallel. Okay. So 1-1 parallel boleh tulis kat sini. Okay, yang ni very important. Kalau you tak faham ni, memang susah sikit. Okay. Salah sekarang tak apa. Okay. Salah sekarang tak apa. So maybe if you salah sekarang, maybe that's how you learn, how you can avoid your careless mistake. Okay. So I have one contributor already. Okay. Yang 2-8 boleh lukis ke? Okay. So if you look at my screen, so this is for 2-4. Okay. So kalau 2-4 that means dia ada apa? 2 U-turn. Okay. Kalau 2-8 that means you have 4 U-turns. 1, 2, 3, 4. Okay. Agak-agak ada tak yang boleh lukis 2-8? Okay, good. Okay. Okay. So yang one parallel, one counter ni memang dah clear kan? It is one is parallel, one is counter. Kalau 28 ni usually is it parallel ataupun is it counter kalau dia tak given dalam soalan? Kalau 28, kalau dalam soalan dia tak given, is it counter or is it parallel? Counter. Very good. Very good. Okay. So I think here you already sketched the layout. So the layout looks good, but needs detail on the labeling. Okay. So labeling here, you don't have it completely labeled. So I can show you, so you can see my screen. Okay. So saya ada buat dalam bentuk step by step ni. Saya ada buat dalam bentuk step by step ni because if I put in step by step, I analyze the information on the left side and I do my solution on the right side. Okay. So sebenarnya here I compare two templates kan. Saya ada bagi dua templates kan. Template 1 dan template 2. So actually template 1 dengan template 2, if you really compare, soalan dia sebenarnya sama. Kecuali, okay, so yang ni yang saya analyze, all inlet temperature given, only outlet temperature not given. So can use LMTD method, okay, sebab only one outlet temperature yang not given. Kalau both outlet temperature not given, then you cannot use LMTD method at all. Okay, tapi untuk template 2, sebab soalan memang ask for NTU. Okay, so this is very important. Dalam soalan heat exchanger, kalau soalan tu minta, kalau dia soalan tu tak specify, then you can use any method yang appropriate. Kalau dia specify that you need to use NTU, so you need to use NTU. Okay, you need to use NTU. Okay, so even though the problem can be solved using LMTD, you need to use NTU if the question asks for NTU. Faham eh? Okay, so this is another thing that you can assume. Okay, sebab soalan ni cakap thin wall, so heat transfer via conduction can be neglected. Okay, so dalam soalan pun tak sebut pasal radiation. Okay, unless specified baru you tak boleh neglect pasal radiation. Okay, so dalam soalan if tak sebut, tak specified, so you can assume that no radiation. Okay, then so yang ni yang saya cakap tadi. Okay, so dekat inlet temperature, kalau counter flow TC in, okay, you kena masukkanlah dia punya label on the mass flow rate, the temperature inlet, okay. The temperature inlet for hot stream, temperature inlet outlet for cold stream. Yang ni cuma one outlet temperature yang tak tahu kan. Then you can determine. Okay, then you can calculate because QC sama dengan QH. Part ni semua orang clear ke? Part ni saya rasa semua orang clear kan? Okay. So yang untuk okay, good. Okay. So for yang 28, so yang ni saya just untuk letak yang 28 lah 28 punya layout. So sama jugalah, okay. So kita assume that temperature layout mana-mana pun apa ni, kalau kita guna energy balance, kita akan dapat temperature outlet hot stream, okay, 1 to 5. So saya rasa yang ni you boleh check balik dengan your answer last time. Okay, you boleh check dengan your answer last time. Okay, so if no question this part, so I'm going to go back dekat sini. Then, okay. So, we all know that since first chapter lagi, kita dah belajar yang overall coefficient ni can be associated to the total resistance. That's why kita panggil dia overall coefficient. Okay, sebab kita associated dia dengan overall resistance. ataupun total resistance. Going to copy this part and okay. Okay, now please circle the answer here. Which one? By increasing fluid velocity in heat exchanger, whether you can achieve turbulent flow or turbulent flow cannot be achieved. Okay, good. So yang lain-lain pun boleh juga. Bukan seorang saja. Okay, you can do this here. Okay, so I think we have completed. So the first one, let me mark it here. So the first one is correct. The first one is correct. The second one is also correct. The second one is correct. Okay. The third one, okay. So the third one is this one. Okay. Actually, that's why you increase fluid velocity also because you want to reduce fouling. So if you imagine, kalau dekat kita punya lantai bathroom, okay, sometimes kita ada molding ataupun fouling kan sebab ada air yang bertakung, okay. So kalau air tu bertakung, then fluid velocity dia very low kan. So that's why dia ada fouling. Tapi kalau fluid velocity is high, sebenarnya you can actually reduce fouling, okay. So this should be the correct one, okay. And then next one, this is also correct. This is also correct. This is also correct. Sorry. If you have too many baffles, so this is wrong. Pressure drop will increase. Okay, pressure drop will increase. Okay, so this is wrong. And then for calculation of NTU, which overall coefficient can be used? So overall coefficient that can be used is both actually. Okay, so why I said so? Because this is UO and UI. So that means tadi kalau you tengok this equation, okay. So this is general equation. So if you have UO, it is 1 over AO total resistance. Okay, if UI, then equals to 1 over AI total resistance. Okay, so both actually applicable for the last problem. Okay, the last question. So I hope you understand this. You have already also listened to this. These are for template 1, template 2, and template 3 for your assignment. So I think you already submit the correct version. I just put it in table form so you can compare. The question asks you to determine the length. Okay, so if you know the Q, okay, you can calculate the area. Okay, you can get the area. So you can compare the area for 1-to-1 parallel, 1-to-1 counter, and also 2-to-8. Okay, and then after you get the area, you can calculate L because area is pi dl. And the question here is whether you need to multiply with 8 for the 2-8 heat exchanger. The answer is no because the L here, the length here already represent the total length, even though it is not specified in the question. Okay, if you miss my explanation, you can refer to this part, okay, for the assignment 2. Okay, template ni, do you want the template? Tapi saya boleh bagi template yang kosong lah. Okay. This template ke? You mean this template? Is it? Okay. So, nanti saya boleh bagi yang kosong lah. Okay. Saya boleh bagi yang kosong. So that you can compare. Okay. Nanti saya kosongkan dulu ya. So, I hope that I have given you the motivation. I hope that I can open your eye so that you can learn from your mistake. And I hope that you look forward, okay? Yang dah lepas tu biarlah lepas. So you boleh continue sahaja. Okay, you can continue sahaja by doing the best that you can. Okay, the best that you can. Because if you do your best, okay, whatever you do it now, you can harvest it later. Okay, so sekarang you tahun 2 kan? Hopefully you can harvest it when you graduated in the 4th year. Okay.